Notice that. How do I check whether x plus 2 is a factor of p of x? Because we are talking about x plus 2, obviously this is x minus negative 2, so this is the a from the synthetic division. Now, the remainder theorem really says that p of x plus 2 will be a factor of p of x only if p of negative 2 equals 0. If p of negative 2 does not, that's what the remainder theorem says. So the remainder of such a division is always p of negative 2. I shouldn't say that. So let me correct myself. So the remainder of this division is p of negative 2. If the remainder, if p of negative 2 is 0, then I will say it's a factor. So that's, I'm using the factor theorem. So I have to find p of negative 2, which is 6 times negative 2 to the 5th, plus 10 times negative 2 to the 3rd, minus 2, and plus 1. All these terms are negative. They will never be 0, plus 1. Yeah. So all I have to say that this is not 0. Therefore,
we get the negative 2 because it's the negative of the...
Because I have to present x plus 2 as x minus a.
Right.
So this division, this divisor has to be x minus a. And that's how I identify a. So one more time, the remainder theorem says that p of a will be the remainder. The factor theorem says if p of a is 0, then x minus a is a factor of p of x. So since I have a negative and a negative and a negative because they're all at odd powers, obviously this cannot be 0. So I will immediately say x plus 2 is not a factor of p of x. That's very clear. Now in part B we are asked to find the remainder, so I have to calculate all this. So p of negative 2, so 6 times negative 2 to the 5th, let's see what we get. If you get that before I do, please tell me. Plus 10 multiplied by negative 2 to, oh, yeah, that's negative 80. I didn't have to do that. And minus 1. I got negative 273. Is that correct? 6 times negative 32 minus 80
Negative 273.
and minus 1. Okay, I got negative 2, correct. Negative 273. So that's part B. And now in order to divide, I'm asked to use a synthetic division. So what do I put in the box? And right here at the very end, what will I have to have?
Negative 273.
That's it. So what goes in the box? Well, the same thing that I plugged in. So it has to be negative 2 because I have to put a in the box. So now the coefficients are 6, but 0, and 10, and then 0, and then 1, and then 1. Now it's a mess. You can imagine if I have to get to negative 273, it's not going to be easy.
Bring 6
So
down.
bring 6 down, and this is negative 12. I bring negative 12 down. Negative 2 times negative 12, 24. And 10 plus 24 is 34. Negative 2 times 34 will be negative 68. And then negative 68 multiplied by 2 will be 136. Plus 1, 137. And then negative 2 times 137, not that bad. Right? So it's negative 4 and 1, right? 6 and 7, yes, and 2.
274.
Right, plus 1 is indeed negative 273.
Yep.
So now I have to present the whole thing. And I know that this is power 5, and I divide by power 1. So what will be the division? So p of x divided by x plus 2 is 6 x to the
4.
minus 12 x to the,
Third.
yes, plus 34 x squared minus 68x plus 137, and minus in front of the fraction line at the top 273 and the denominator x plus 2. Yep, yep. Very good. So this was this topic, number 4, factor, remainder theorem, and synthetic division.
That's a carried over to minus sign, right? It's not minus minus.
No, because if I don't put something here, I always
Right.
think that it ends and nobody will look
Right.
underneath. No, it's not minus minus. It just says look for this because it continues somewhere. But again, it's just a matter of habit. If you know you're going to look underneath, then you don't have to put it twice. Good. Next topic.
Can we do a word problem trick to find a distance or height?
Yes. So those are in chapter 6. On page either 482 or page 475. Let's look at the height of a tree. This is again a useful application.
Which number is that?
I'm looking at problem 39 on page 474. So we have a hill and we have a tree. Don't make me draw a tree. Sorry about that. Okay, a tree on a hillside casts a shadow of 215 feet down the hill. So from here, (215). So the sun is somewhere here, and this is the shadow on the ground, of course. If the angle of inclination of the hillside is 22, so this is 22 degrees to the horizontal, and the angle of elevation of the sun is 52. Okay, so this is 52 and the sun is right here. Find the height of the tree. What I recommend in these kind of problems, always take that triangle. I shouldn't say always. I recommend that. Take the triangle out of there. So this is my situation, really. Okay, I have this 215. I'm looking for this height. And I do have this angle because this one is 52 degrees. 52 from here to the horizontal, and this one is 22. So therefore I have this, which is definitely
30.
very good. And somehow this is not a right triangle, so somehow I have to determine something else. I can also determine, yes, I can extend the tree as if I could. I can't, but so I know that this is now 90 degrees. And then I will be able to determine this if I'm able to determine this, I will have this angle.
Yeah.
So this is 90. This piece is 22. Therefore, I have this piece. And if I have this piece and this is 180 here, if I have this piece, then I have this piece. So from so this is 22. 90 minus 22 is this angle right here, this one. 90 degrees minus 22 degrees.
How'd you get to 68?
Because this is 90. So in this triangle, this is 90 and this piece is 22.
Oh, yeah.
If this is 22, this is 90 minus 22. So 90 minus 22 is 68. If this piece is 68, then from 180, I subtract 68 to get this piece. So this piece is 180 minus 68 degrees. So I also have this piece, which is 112 degrees.
Yeah.
So basically I have all angles in this triangle, but I really don't need all angles. So now what will I use?
Sine.
Law of,
Sine.
yes. So let's write the two proportions, one proportion, I don't need the third one. One proportion that will help me determine x. So if I have 30 here and 112 here, let's determine the other one. So this is 180 degrees minus 142. So this is 30, this is 112. So 30 plus 112 is 142. 180 minus 142 will give us this angle, which is 38. So what will you write?
Sine 38 over 215 equals sine 30 over x for a.
Sine 30 divided by x. This is useful. This is a useful type of application to determine the height of the tree. So, of course, I'll cross multiply. Now, you know you don't have to write the intermediate step anymore because you know this times this equals this times this. So you have x equals 215 times sine 30, which you know you don't have to punch that in the calculator, is 1/2, divided by sine 38. So how much is x, or the height of the tree, in feet?
I got 174.6.
Very possible. 174.6 feet.
So yeah, so I have to.
Okay. Very good. Okay, next topic.
Can we do a solving trig equation?
Yes,
Test 3.
yes. So let's look at chapter 7. Chapter 7 at the end of the chapter. Page 531. Um, 42 caught my eye. 42 on page 531. Cosine 2x times cosecant squared x equals 2 cosine 2x. By simply looking at this equation, what would you say immediately before you even attempt anything?
Yeah, like what's that cosecant doing, right?
Try to simplify it.
I cannot simplify because there is nothing I can divide by, and I cannot divide by an expression that has x in it.
Okay.
Let me go back because I'd like to talk about this for a moment. If you solve the equation, let's say x to the fourth equals 2x squared,
Yeah.
you can say, my professor said to always simplify equations, right? And you divide both sides by x squared, then you will have x squared equals 2. And you take the square root and you get the only solutions plus or minus the square root of 2. That would be a terrible mistake. Why? What is the degree of this polynomial?
4.
How many solutions do I have to write?
4 solutions.
So if you eliminate x squared twice, you don't even remember that there is don't even see that there is a term at x squared because it's a double solution, multiplicity 2. So I can never divide an equation both sides by anything else but numbers.
Yeah.
So we cannot divide by an expression that has x, because then we end up with fewer solutions than we should.
Okay.
So this is not allowed. So let's look again. What do we notice here?
Squared, so I have 2 solutions.
Yeah. Well, we'll have to wait and see what happens to the cosecant squared. Anything else?
You have cosine 2x on both sides.
Right, in both terms.
Yeah.
So what do I have to do right away? Right? Well, I have to set it equal to 0 and factor.
Yeah.
Right? Remember, factor, simplify, clean it up.
Yeah.
At least one of these, or maybe more than one, has to be applicable. So I'll have to set it equal to 0, because I have no other option. If I don't set it equal to 0, then I won't be able to do anything. So I have cosine 2x multiplied by cosecant squared x minus 2 cosine 2x equals 0. And I am halfway through, because I will factor out cosine 2x, and I have in parentheses cosine squared x minus 2 equals 0. I already have one option. What is one option so far? That what has to happen? What has to happen here? I have a factor times another factor equals 0. So what do I have to write immediately? Okay, this is factor A and this is factor B. If factor A times factor B is 0, what are the options?
A is 0, 1, B.
Right, that's all I want you to say.
Oh, okay. So cosine 2x equals 0, and then cosecant squared x minus 2 equals 0.
Yes, exactly. Let's solve the first one. Cosine 2x equals 0. I'm thinking now. Cosine is measured on the x-axis, and it's 0 at so where is cosine 0? It's measured on the x-axis. It's 1 here, and it's negative 1 here.
Yeah.
So where it's 0?
Pi over 2.
Pi over 2 or?
3 pi over 2.
Correct. So the argument is not x, though. I have to write 2x equals pi over 2 plus 2 pi k, or 2x equals 3 pi over 2 plus 2 pi k. Of course, I have to write that just once. 0 plus or minus 1 plus or minus 2 and so on and so forth. And I have to solve for x now. I only solved for 2x. So look at the steps. Let's review the steps one more time. First, I factor, right? I have to have 0 on one side and factor. Secondly, I say, okay, I see two factors. The first factor is 0. Then I say, okay, what can x be when cosine 2x is 0? Or what, I should say, what can 2x be when cosine is 0? And then I say 2x can be this or this, because that's where cosine is 0. And the final step, I have to divide by 2. So x equals pi over 4 plus pi k, or x equals 3 pi over 4 plus pi k. I divided everything, both sides, by 2. So for now, I'm done with cosine 2x. But I have to come back to the original equation, or this step, right? Because I have something else to do here. So I have cosecant squared x equals 2. I have to remember something very important. If a trig equation is given in sine and cosine, there are no restrictions, because sine and cosine exist for any angle. But for any other trig function, tangent, cotangent, secant, cosecant, I have to state a restriction. And when I'm done solving this equation, I have to make sure that in this case, which is cosecant is 1 over sine, I have to write that sine x is not 0, because whatever x I get, if sine of that x is 0, the solution has to be excluded, because cosecant will not exist. It has vertical tangents there. So sine x equals 0. I don't have to check this, because these solutions do not come from here. But if you want, it's very clear. But I don't have to check for cosine 2x. I have to check only for solutions that come from here. Okay? So now you can say, I don't want to work with cosecant squared. And I will say, I agree. But you have to write sine squared equals 2 and then swap them. So sine squared equals 1/2. And sine squared x, of course. So now you can say, now this is a piece of cake. So you should never get scared by any function, because you can always go back to simple things. And especially in these situations with secant and cosecant, because you change them directly or immediately to either sine or cosine. So this was this. I swap these two. I'm allowed in a proportion. So I have sine squared equals 1/2. And now I have to take the square root. And I do get the sine x. Remember, it's 1 over the square root of 2, but I have to rationalize it. And it's plus or minus the square root of 2 over 2, because I have to have 2 solutions. And of course, 2 solutions will come from the square root of 2 over 2 positive solution, and 2 solutions will come from the negative the square root of 2 over 2. And whatever I get, sine will not be 0, because sine would be 1/2.
Yeah.
1 over the square root of 2, or the square root of 2 over 2. So I'm safe with all of them. So for this situation, I have to have this solution, then this solution, then this solution, and this solution. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Including these two. So x will be pi over 4 plus 2 pi k. X will be 3 pi over 4 plus 2 pi k. You can condense them if you want to. X equals 5 pi over 4 plus 2 pi k, and x equals 7 pi over 4 plus 2 pi k. Although it looked difficult, once you move everything to one side and factor and set it equal to 0, then it's not that bad. Good. Anything else? Next topic. Nico, if you would like to make a correction here, or number 8, I had the typo. Instead of I, put N. Number 8. It's either N or I. It cannot be both. So,
Gotcha.
so put N here. And you can, if you want to change all of them into I, you can, but it's more work. So just replace, instead of I equals 1, put N equals 1. Okay, next question, next topic. Are we okay with difference quotient?
Do another one. Let's see if one.
Okay, let's invent a function.
Alright.
It can be rational, it can be polynomial, not beyond degree 2 because it's going to be tremendous work. So quadratic, rational, or radical.
And rational.
Right, the rational is the most difficult one. I mean, not difficult, but cumbersome. Okay, so let's create a rational function. And if you stay with linear at the top and linear at the bottom, it's not going to be that difficult.
Right.
Now, if you put x squared plus 4 over something else,
Okay.
it's going to take a while. So, no, I will put a linear over a linear.
Okay.
Because I'm not testing endurance.
2x minus 3 over 4 minus x.
Good, it also has a twist in it. Okay, here's what I would do immediately. I don't care for that negative. It can wait for me. When I'm done, I'll address it. So now I have to find f of x plus h. In this class, you're not required to remember the difference quotient, but in the next one, you have no choice. I'm sure you remember it because we worked with it for so long. But if you don't, it's okay. You will be given it. Okay, so can anyone dictate? So, see, that's another idea that I would like you to remember. When you look at a function and say, what is that? Put a minus in front and clean it up. Why? Because it will be more difficult to multiply. And this, I'll show you what I'm going to do with it. It can wait. And it will wait outside of the difference quotient completely.
Okay.
And that's, again, very important for calculus to see that or understand that. So f of x plus h will be 2 times x plus h minus 3 over x plus h minus 4. And yes, I recommend you should distribute 2x plus 2h minus 3 over x plus h minus 4. So now the difference quotient is f of x plus h minus f of x divided by h, as we know. I have to put all pieces together. And then we'll factor out -1 or not, but I don't want to put it in the function. So we'll see what looks best. H in the denominator. At the top I have negative 2x plus 2h minus 3 divided by x plus h minus 4. And minus this, which is positive 2x minus 3 over x minus 4. Now you have two options here. You can keep the negative in front of the first fraction, or put it in front of this fraction, changing this sign. Okay.
Yeah.
So leave the negative outside. It can wait till we are done. So 2x plus 2h minus 3 divided by x plus h minus 4. But don't forget to change the sign here, because you are pulling out -1. If you're pulling up -1 from the first one, you have to pull it from the second one. And that changes into 2x minus 3 over x minus 4 divided by h. It is wise to work on preparation because then later on it will be easier.
Yeah.
So it's not a mistake to take your time, rearrange, simplify, Clean it up before you start. That's always a wise thing to do. Okay, so now the numerator. So still minus in front, don't forget that. I have to find the least common denominator in the numerator. And I know that it has to be the product of the two because they have nothing in common. Look, this is a linear factor. There is nothing you can factor out. There is a linear factor. There's nothing you can factor out. So this is like 2 and 3. So it has to be the product, which is x minus 4, x plus h minus 4. Okay, the top of the first fraction needs to be multiplied by what it does not have, and that is x minus 4. The top of the second fraction needs to be multiplied by what it doesn't have, x plus h minus 4. So far, so good? Okay. And now I recommend distribute from the binomial. I'm not saying it's wrong to distribute from the trinomial, but I think it's easier to keep track of terms. So x multiplied by 2x will be 2x squared, and x multiplied by 2h plus 2xh, and x multiplied by negative 3 is negative 3x. Now I have to distribute negative 4 to these three terms. So minus 8x minus 8h and plus 12. Now I'll do the same thing, but be careful now with the minus. Minus 2x times these 3, and then minus times negative 3 times these 3. So minus 2x squared minus 2xh plus 8x. And then plus 3x.
2xh because you have a negative and a negative.
So let's do this again. Negative times 2x.
Oh, I thought,
times,
never mind, I missed that.
it may happen to me. So negative 2x, okay, negative 2xh, and then positive 8x. And then positive, because negative 3 times negative 1 is positive 3, 3x plus 3h minus 12. Is this okay? What has to happen? Every time I determine the difference quotient for any function on the planet, two things have to happen. What is the first one?
Everything without an h has to factor out.
Yes, it's possible that other terms go away.
Yeah.
Fine. But at least those without h must go away.
Yeah.
Good. And what is the second thing that has to happen? Eventually,
The h on the bottom.
this one, so the final simplified form may still have h in it, but not that one.
Right.
So two things are very important. One, some terms could cancel out, but definitely the terms without h must go away. So I can factor out an h, so I can terminate this one. I cannot terminate this one if I won't be able to factor out an h from the top. Okay, so now I have to simplify. So these two go away, 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 and the numerator has negative 8h plus 3h. So it's negative, don't forget to copy the negative in front. Now negative 5h at the top, x minus 4 times x plus h minus 4. And flip the denominator 1 over h. So simplify the h with the h. The minus with the minus change into positive. So this is 5 divided by x minus 4, x plus h minus 4. Students in calculus class who either didn't have a strong background, or they just forgot, or they came back after a few years of a break, which, you know, we all forget, so I can't blame them for that. Say, calculus, very easy. Algebra, very hard. But there is no way we can make any steps in calculus without algebra. Okay, so that was a difference quotient.
Any question about the difference quotient?
Yes.
Whenever you're finding common denominator.
Yes,
Every time we've always done it, they've never had anything in common.
that's true.
That's just always.
Yes.
Okay.
Yes. Let me explain why. Because one of them has only x in it, and the other one has x and h in it.
Okay.
They will never have anything in common. One is the function of x, and the other one is the function of x plus h. So it's like saying, what could f of x plus h have in common with f of x? The answer is nothing. Yeah.
Okay.
Very good question. Good, next topic. So that was a difference quotient. Domain of functions or graphs or,
Domain, sure.
okay. So for example, I would like to look at domain in chapter 4. So I'm looking at the end of chapter 4 if I find it today. Okay. On page 355, I'm trying to find a domain. If there is none, then we'll make one up. There's nothing. Okay, so I'm going to look at same chapter 4, but go back to page 323. Find the domain of the function, please choose 63 through 68. 323. Okay. 68. Good. I think you picked the same problem.
Oh, we did?
Maybe, I'm not sure.
Oh,
Good. Okay, so let's look at this function h of x, and please tell me what you notice. We notice that this is difference of
functions.
two functions. So if you want, this is f of x, and this is g of x. And what am I looking for then?
Intersection.
Exactly, the common domain of these two pieces. Because if these two, if one of them is defined on negative infinity to 0, and the other one is defined on 2 to infinity, I'm done. There is no common territory. This function means nothing. Because there is not one single x that I can plug in it. Because they don't exist at the same time. So I'm after common domain. So always when you look at a ratio, for example, same idea. Because that's what we had on that test that I just returned. Good. So what do I have to write?
The restriction.
Yes. What will I write for the first one?
X minus 2 is greater than or equal to 0.
Very good. What if I had here 1 over? 1 over the square root of x minus 2. What?
Greater than 0.
Exactly, because in the denominator. Good. And what about the other one?
X minus 10 has to be greater than 0.
10 minus x has to be strictly greater than 0 because law cannot be applied to 0 or negative numbers. Good, perfect. So the first one is x greater or equal to 2, and the other one is x less than 10. Now, of course, if you feel that there is a need to graph this, graph it. No units are required. Just a simple graph, 0 in the middle, negative infinity to infinity. Greater than or equal to 2 is this. And less than 10 is this. So if orange and brown overlap, then h of x makes sense. If they don't, h of x means nothing. Because what's a function if I cannot plug anything in it? It doesn't mean anything. So the domain of h will be
bracket 2 or 10 brackets.
very good. Okay, next question or next topic.
Can we do a graph and ellipse or a conic?
Yes, of course. Of course. So back to chapter 11. Let's say we're asked to graph x squared equals 4 minus 2y squared. Okay. And everything else, it will be a list, but I just don't want to tell you what it is just yet.
Well, we know x is squared and y squared.
Say it again.
We have an x squared and a y squared.
Correct.
So it can't be a parabola.
Parabola.
Or a circle.
A circle could be, a circle could be, but because there is a 2 in front of y squared, right? Just to continue your thought, if I have x squared and y squared, it can be a circle. But because there is a number in front of one of the two or both, then it cannot be a circle. You're correct.
Wait, it can't be something else. I'm not remembering.
A parabola.
Parabola.
Because the parabola does not have x squared and y squared. It either has x squared or y squared. So very good. It cannot be a circle. It cannot be a parabola. It can be then
An ellipse.
or
Hyperbola.
hyperbola. But I will know very, very soon whether it's one or the other because I have to do something very important.
Bring y squared
Yes.
to the
So
other
once I
side.
have x squared plus 2y squared equals 4, I can already eliminate one other.
No hyperbolas.
Exactly. Because a hyperbola has to have a minus, either in front of x squared,
Or the y
which will
squared.
be on a transversal axis on the y-axis, or in front of y squared, which will be on the x-axis. So it's definitely an ellipse. No question about that. Good. What will be my next step then?
We need 1 on the
Yes,
other side.
absolutely. So I have to divide, yes, plus y squared over 2 equals 1.
That's right.
So then I know that a squared is and b squared is, and I know whether the major axis is on the x-axis or on the y-axis.
Major is on the x-axis.
Correct. So a squared is 4 and b squared is 2, which means a is 2 and b is the square root of 2. Very good. Good.
The center at 0, 0.
Yes? So 2 on this side, 2 on this side. This is 1.41. So somewhere here, somewhere here, somewhere here, and here. So now I can tell you this problem is actually problem 20 on page 739. So negative 2, 2, the square root of 2, negative the square root of 2. Okay, very good.
Then we need to find the foci also.
Yes. So we know that f1 will be negative c comma 0, and f2 will be c comma 0. And we know that c is the square root of a squared.
Or minus
Yeah.
b squared.
So c equals the square root of 4 minus 2. So c equals the square root of 2. So 1.41, somewhere here is f1, and somewhere here is f2.
Isn't that only though for like the distance because it's centered? So I know in the last test of foci was you have to shift it from the center of the ellipse, right? The
If
ellipse was shifted
but-
5 to the left.
right,
Yeah.
because the in this case, if the center is 0, 0, then f1 and f2 are on the x-axis.
Okay.
And the eccentricity is c divided by a, so the square root of 2 divided by 4. So I'm going to approximate this. What is the square root of 2 divided by 4?
But a is 2, right? So a squared is 4.
Oh, I did right. Thank you. Thank you. 0.71 approximately. That's what we expected, a number between 0 and 1.
Yeah.
The length of the major and minor axis. So major,
4.
yes, and minor
3 times square root of 2.
to the square root. Very good.